All right, this video is going to cover a couple challenges related to Venn diagrams, and I really encourage you to pause this video, try these on your own, and then check back in and see how you did. So the first one on the left is a 3-category Venn diagram. All right, so 3 overlapping circles, and you see I have an image pasted down below that gets that set up for us. And then the image on the right is one we'll do second, or the problem on the right is one we'll do second. So let's do this one on the left first. So we know that 120 people attended a movie, 65 of them bought a soda, 75 of them bought popcorn, 20 got candy. Okay, and then various numbers of people bought various combinations of things. And how many people didn't purchase any food or drink? Okay, sounds like there's a lot going on here, but let's try to get this set up. I am going to draw first my sample space as a large square. And that is going to be the number of people that went to the movie. So this is sort of our movie category. That's everybody. That's 100%. So that's 120. Okay. Let's do a little color coordinating here. Let's say movies yellow, so that'll be our top circle. Wait, that'll be soda. Movies everybody. So let's have soda be yellow, okay? Let's have popcorn be green. And let's have candy be blue, how about? Okay. So that helps us kind of visualize what's going on. Let me just write those down. So this is soda, blue is candy, and green is popcorn. Okay, cool. So we can fill in some numbers. And again, when I'm filling in Venn diagrams, I like to fill in the overlapping pieces first and then kind of gradually work my way out. So we know that 7 people bought all 3 items. So that means we have a 7 right in the middle right there for sure. 32 people bought soda and popcorn, but 7 of them are already accounted for. So that means we have 25 people left over in the soda and popcorn only zone. 10 people bought candy and soda, but 7 of them bought all 3, so we have 3 people left over there. Okay, let's actually check things off as we do them. So we did that, we did that, we did that. 42 people bought only popcorn. So that's the next thing I want to figure out. 42 bought only popcorn. Okay, I didn't buy any candy or any soda. So we can gradually fill in the rest, I think. I'm going for this one next. The candy, popcorn, but no soda. And so we know that 75 total people bought popcorn. So these 3 numbers have to add up to 75 once we include that number as well. So the 4 numbers add up to 75. So I get just 1 person in there. And I want to make sure I did that correctly. 32 plus 42, 74. Yep, so 1. Okay, so we did the popcorn thing. 20 people bought candy. Okay, we can do that now. We have 11 people already accounted for on our candy zone. So 9 more people just bought candy. And then 65 bought a soda. So these numbers have to add up to 65. So let's figure that guy out. So that's a 30 right there. And I want to double check that math. 3 plus 7 is 10, 40, yep, 65. So that all looks good. And now we're really being asked how many, whoops, let me undo that. We're really being asked how many people didn't get any food or drink. So no candy, no soda, no popcorn. So we have a whole bunch of numbers that we can add up right now. And so all of these numbers we just need to subtract from the total of 120. So let's just carefully add them up. 30 plus 35 plus 10 plus 42. So we have a grand total of 3 people left over, okay, to get to our 120. All right, moving on. In a certain community, 70% of people are cat lovers and 80% are dog lovers. What are the upper and lower bounds for the number of people that are both dog and cat lovers? And let's actually, I think rather than number of people, let's have this be percent, because we don't know how many people we're actually dealing with. Okay, I'm going to try to draw a picture here to see if this helps. So let me draw a rectangle first. Let's see if I can get that in. All right, and this is going to represent my whole. So this is going to represent my 100%. And let's actually make that exactly 10 squares. If we can get this to fit here. Okay, and so that's our 100%. And let's put cat lovers in red. And so we have 70% of people are cat lovers. So let's just get that locked in here. 3, 4, 5, 6, 7. So that's our cat lover zone right there. And that's 70%. Okay, out to right there. And I am going to copy this square and get it down here and then edit it a little bit. And let's see if we can get a dog lover zone of 80%. And let's have dogs be blue. Okay, and I'm going to say this is 80% right here. Okay, so let's make sure that all makes sense to you, okay? And so now what we can do, and that ends right there. What I want you to do is think of the dog lovers box as sort of a sliding scale on top of the cat lovers box, okay? And let's see if we can get this to visualize it a little bit better for you. So it's possible that all 70% of the cat lovers are also dog lovers. That's a possible thing, okay? Let's see here, just a second. Okay, and that's what this would look like right here. So we could have 70% in both, right? Okay. However, we could also overlap it like this, and it would be possible to have only this chunk, right here be our overlap. Okay, so that would be the smallest amount that would be possible. Okay, so what percent is that? It looks like it's 50%. Okay, so it would be possible to have as much as 70% and as low as 50% of people fall into that overlap of loving both dogs and cats. Let me try to explain that one more time. Basically what we're doing is we're trying to take my 80% and seeing how far we could shift it left or right relative to my cat picture. Okay, so in that picture, in that example right there, we have a 50% overlap. We have these 20% of cat lovers don't like dogs, and these 30% of dog lovers don't like cats. Okay, so we have 50% that like both. But then, however, we can also move this to the left, and then we have a 70% overlap. Okay, so my final answer is going to be the lower bound is going to be 50%, and the upper bound is going to be 70%. A great challenge that I'm going to leave you with on this is to try to use the formula to see if you can come up with those bounds as well. So don't use a visual representation. All right, that's a good place to stop on that one right there.